Okay, now we're going to set up the model for optimization. Here our decision variable is how many seats should you set aside for Y class, right? Okay, let me put these side by side. Okay, so we're going to set that as a decision variable where we will use that would be the number of seats that we will be setting aside. Okay, and we can enter an initial value which we found from previous analysis. So that would be 34. Okay. Then constraints, we've already set them in the model. Well, we have to set this up again, I guess. Let me, so we should have probably started with the model. Let's quickly do this. We've already done this several times. So number of seats available minus what is reserved. So Q demand is risk normal, Q class mean and standard deviation, and then risk truncate 0 comma. Okay, and then we round that. Okay, take that, put that here, and change E3 to E2 and F3 to F2, and Q sales is the minimum of Q demand and available sales. So these kinds of constraints are getting modeled in the Excel sheet itself. So this is a constraint. Sales of Q cannot be more than demand or cannot be more than what is available for Q, and we are hard coding those constraints in the model itself. So you don't need to put that in risk optimizer. Now the seat capacity minus Q seats sold, that's what is available for Y. And then Y sales is the minimum of Y demand and what's available. Okay, so revenue is Q sales times Q price plus Y sales times Y price. Empty seats is 100 minus what we sold, the seats sold, Q and Y together. Okay. This is our, let's highlight only the revenue. That's the output. Okay, so let's go ahead and define that as output. That one, output. Okay. So now we're going to the objective function. So we're going to set up the model, optimization model. So objective function is cell F6. The constraints, we've already hard-coded constraints. The only other constraint is, so you want to search for the best number of seats to reserve, and we can set up a minimum value, a range of values that we want to try. Okay, so let's do that, and so that's the user decided value. Okay, so let's expand that. Okay, so So now we have the model set up. All right. So now instead of using simulation, we have to use optimize. Okay, so you go to optimize, and there are three things that we will do. So would start the optimization. So we'll start from model, uh, setting the model up. That is called model definition, and the cell for the objective function is the revenue cell, which is F6, and we want to maximize that. And we will be running simulation like for 10,000 times and so on and so forth. And what from that cell you want to maximize? You want to maximize the mean, or you can minimize the standard deviation, and so on and so on and so on. And let's keep it simple. So mean. We want to maximize the mean. Okay, and it is a standard type analysis. Okay, we can do efficient frontier. We'll do that later. Okay, so here are the two kinds of constraints that we can set up. Here we set up constraints for the uh, the decision variable. Decision variable is how many seeds to put aside. So we have only one decision variable, but you can have several. So we can add them up here, and then we can set limits to the values that we want to try. Okay, and here are the other constraints. If you have other constraints that you want to set up, which are not directly a range type constraint for the decision variable, we can set them up here. But for this problem right now, we don't have any of this type, so we only have this one. So we can then set up a range. Okay, add. All right, so select adjustable cell range. So that's the one that we want. Okay, so H1. Okay, so H1. We want H1 to be, okay, the minimum value is 25. So we can either hard code it, or better set up the range here. And then the maximum value is that. Okay, so you want H1 to be in this range. Okay, there is one more thing we have to do, and that is you have to, if you say any, it can take any value in between, and that's not so. It has to be integer. Okay, and you can also say that, well, you don't want all the integers. We want in steps. Okay, discrete step 2, step 3, step 4, and so on. This is especially useful when you have a large range of discrete values to consider, and if you have to look at each and every value, then you end up with too many values, and the computational burden will be very high. So for now, let's just say integer, because it's a small problem and we have only few values, like 26 values, so it's okay. All right, so let's change that to integer. Okay, so we've clicked OK, and then we can do settings. There are some setting options that we can set. We will do this later on. The trials is how many different trials we're going to have. We're going to have only about 26 trials, and our default setting is 1000, so it's not going to matter for this particular problem. Okay. All right, so now you go and say start. Okay, now it's completed. Now you can look at the progress. Okay, there is a summary here. It says the best is the trial 1. Original is trial 1. The last trial is the 26th trial, so we went from 25 to 50. 26th trial will be the 50th trial, and the um, corresponding H1 values, you see 34 is where we started, 34 is the best, and the last one is 43. Okay, so now if you look at the log, it gives you all the trials, so from 1 through 26. It gives you the results, the mean, standard deviation, and all the rest of it. Okay, and then stopping options. So when you click OK, these are the options that will be performed. So here you can select what kind of reports you want to generate. Okay, so you want optimization summary and the progress steps, for example. So if you want all the trials, that's fine too. So since we have only a few trials, let's check all of them. Usually you don't want this. If you have like hundreds of trials, you don't want to check that. So you can put these reports in a separate workbook, or you can put it right here in this workbook itself. So let's just say take it, select active workbook, which will be just this workbook. Okay, so we have the results. So we started out with the best, and then it never improved after that. That's why you have a flat line here. And here are some summary statistics. Okay, and operation log trials 1 through 26. Okay, the mean value and the log, the best result, and that's it.